Hello and welcome back. In this video we will cover the material in the first homework assignment, which is all about exponents. This should be a review. I'll start with some terminology. The integers are going to be essentially the whole numbers. We have positive integers, 1, 2, 3, and so on. We throw in 0, and we also have -1, -2, -3, and so on. So integers are positive and negative, nice whole round numbers. Rationals are going to be anything of the form n divided by m, where n and m are integers. Note that we can't divide by 0, but any integer divided by any other integer is going to be a rational number. And it's sort of important to keep in mind that not every number is rational. Some numbers will be irrational. So, for instance, the square root of 2 is irrational, a famous irrational number. Pi is another irrational number. E is another irrational number, and so on. So essentially, irrational numbers are any number that is not rational. And real numbers are just essentially all numbers. And it's anything that is rational or irrational. So all rational numbers and all irrational numbers make up the real numbers. Now, there are complex numbers. So for instance, the imaginary number I, which I don't think will come up in this course, but there's a lot of mathematics surrounding I, and it has a lot of uses. I think in this course we are really going to be focused on real numbers. We're not going to talk about rational versus irrational numbers very much, but it may come up every once in a while, and knowing what the integers are will be helpful. So for instance, when we're focusing on exponents, the first sorts of things that we want to look at are integer exponents. So if we have a positive integer exponent, say if we have b to the nth power, typically this just means that we're going to take b times itself n times. Before I do some examples, if we have a negative exponent, that just means that we're going to flip the fraction over. So b to the n is just b times itself n times. B to the negative n just means b times itself n times, but on the bottom of the fraction. So whenever we see a negative exponent, we're just going to put on the other side. So if it's in the numerator, if it's on top, we move it to the bottom. If it's on the bottom, we move it to the top. So again, some very basic examples. 2 to the 5th power is going to be 2 times itself 5 times. And if we do all this out, this is just 32. And 4 to the negative 2, well, this is going to be 1 over 4 to the 2nd power. 4 squared, 4 times 4 is 16, so this is going to be 1 over 16. So far, so good. The only integer that we haven't talked about is 0. Anything to the 0 power we will treat as 1, except 0 to the 0. So if you have a positive number to the 0 power, it's 1. If you have a negative number to the 0 power, it's 1. But the only time that something to the 0 power isn't 1 is if we have 0 to the 0, which is undefined. And there are reasons for this that I don't necessarily want to get into, but the main motivation behind this is 0 to the 0 power we want to think of as 0 divided by 0, and we can't really divide by 0. So ultimately, b to the 0 power is just like b divided by b, which is 1, except we can't divide by 0. So this is just a very nice thing to keep in the back of your mind. So we have a product rule and quotient rule for exponents. If we multiply b to the m and b to the n, we will get b to the m plus n. So what started as multiplication down below becomes addition up top. And this makes sense if we think about it. B to the m, that's m b's in a row all being multiplied together. So we have b times b times b all the way up to b. So we have m, let's see here, we have m copies of b here, and if we have b to the n, we have b times b times b all the way out to there. And how many do we have here? N. How many do we have altogether? M plus n of them. So again, product rule kind of makes sense if we think about it. Oh, we've just got a bunch of b's that we're multiplying together. The quotient rule is a little bit harder, but we can reduce the quotient rule to the product rule pretty easily. If I have b to the m times b to the n, or sorry, divided by b to the n, I can turn everything into just a regular exponent. Since I'm dividing by b to the n, it's on the bottom of a fraction. If I move it to the top, it's as if I had a negative n there. Again, negative exponents means that we're going to flip it to the other side of the fraction. So I can flip b to the n to the top to get b to the minus n. And what happens when we multiply? We're just going to combine the top. So m plus negative n is the same thing as m minus n. So again, if we're dividing, we're just going to subtract the exponents. So let's go for it down here. Let's multiply 6x to negative 2y to the third power by 6 times x to the 10th power y to the negative 4th. Multiplication, it doesn't matter what order we're multiplying in. We are multiplying essentially everything in here, so we can do this out of order. So I can multiply the 5 and the 6 first to get 30. I can multiply the x to the negative 2 times x to the 10th power. It's going to be x to the negative 2 plus 10. And then the last one, I have y to the third power times y to the negative 4th power. So it's going to be y to the third power plus y to the negative 4th power. And if I simplify this a little bit, well, the 5 times the 6 was the 30. We saw that right away. X to the negative 2 plus 10. Well, negative 2 plus 10, well, that's 8. And then the last one, y to the third plus negative 4th. 3 plus a negative 4, well, that's negative 1. And this we can simplify a little bit further. We have a negative exponent, so we can put that on the bottom of the fraction. And voila. So here would be the simplest way to write this. And by simplest, I mean without any negative exponents. Looking at the next one, we've got 5 times... So it's the same thing, same two things here, except I'm now dividing. I find it easiest to change all the negative exponents to positive exponents by moving them to the other side of the fraction. So again, 5, that'll just stay on top. The 6 will stay on the bottom. I've got an x to the negative 2. Well, negative exponents aren't very nice to work with, so I'm going to move it to the bottom and make it positive. So I'll have an x squared. I'll also have an x to the 10th power, and that's just on the bottom. I've got a y to the third power on top. And I've got a y to the negative 4th power, but again, negative exponents aren't the best, so I'll move that to the top to get y to the 4th power. And now I can really start simplifying. Y to the third power times y to the 4th power is going to be y to the 7th power. Again, fairly straightforward. We've got the 5 there. We've got the 6 on the bottom. X squared times x to the 10th power. We'll end up adding the exponents to get this. So when we divide, here's what we get. Next up, we've got the power rule and some distributivity. So the power rule, if I have b to the m to the nth power, what was an exponent becomes multiplication. So it's b to the m times n. And one way to think of this is, what is b to the m to the nth power? Well, I'll have b to the m times b to the m times b to the m a bunch of times, right? And what happens if I add all of the exponents here, m plus m plus m, n times, well, that's just m times n. This also works for distributivity. I can distribute powers here. So this will become a to the n, b to the n. And again, why would this be true? Well, if I take a times b to the nth power, this is going to be ab times ab times ab times all the way out to the n ab. So how many a's do I have? Well, n of them. 1, 2, 3, all the way out to n a's. 1, 2, 3, all the way out to n b's. And there they are. It is really tempting to try to apply this if we're adding. And it's really tempting to try to write a to the n, b to the n, and write this. However, this is not true. So this is something that I'm sure people will make a mistake at some point and try to do this. Just know ahead of time. This is called the freshman's dream, because someone comes into a math class and goes, haha, I know how to do this, and they make the silly mistake. So please don't make this mistake. It's bound to happen at least once, so I just want to give you a heads up ahead of time. So let's do some examples. So here we have x to the third to the 7th power. Again, the way this works is when we have an exponent to an exponent, we're going to multiply. So this is going to be x to the 3 times 7, which is x to the 21st power. Again, we can think of this as x to the third times x to the third times x to the third 7 times. So then 3 plus 3 plus 3, 7 times is going to be 21. Likewise, when I have an exponent and I can distribute it across multiplication, not addition, but multiplication. So here, this is going to be x squared to the 10th power, and this is going to be y to the negative 1 to the 10th power. Here, I have x squared to the 10th power. Again, if I am raising an exponent to an exponent, I can multiply. So this is going to be x to the 20th power. And this is going to be y to the negative 1 to the 10. Negative 1 times 10 is going to be negative 10. And again, negative exponents, I normally want to write it without negative exponents. So I'm going to simplify that to y to the 10th power.